Hello everyone, welcome back to the shopping cart series. In this video, we are diving into how we can implement service using Axios. This would be more of a sidebar, so we will not be changing anything in the existing application. The experience and everything would remain same, but we would make our service a little more robust. And this is to accommodate some requests that I've been getting to show the implementation using Axios. So first thing, why Axios? So the major reason why most of the larger projects that you would come across would be using Axios is ease of use. So it is very easy to use, has a very simplified syntax compared to fetch, and you don't have to worry about the underlying things, what's going on below. So that is definitely one of the top reasons. You plug in the library and you're ready to make service calls, REST calls with the use of library. Then the default configurations are a little better. As you would have seen with our service implementation, we are converting the response to JSON. But Axios by default handles the JSON response type out of the box. Then you have centralized error handling, which is your ability to manage errors consistently across the application. In our case, we do not have that, but before creating a very robust service, we will go ahead and enhance the service a little to have this functionality as well. Then you have the concept of interceptors. So interceptors are very ideal for logging, modifying requests, or adding authentication tokens, which you would want in all your HTTP calls, but might not want to add them separately on each of the places where you're making the call. So that's where interceptors come in really handy. And then it's really scalable for larger projects because of all the points that we mentioned. And also the documentation is very exhaustive. So before we dive into creating a service using Axios, we would also have to upgrade our service. But before that, let's just have a look at our bare bones service, what we are talking about. So this is something that we created in one of the previous videos. I would add a link to the video. So if you want to go through this implementation, understand what we've done a little better, you could go ahead and understand that. And then in here, as we can see, it's a very basic implementation. You have two methods, get products and get products by ID, which are fetching the products from the respective URL. There's no error handling. There's no logging. And these are some of the things which are qualities of a robust service. So, as a part of our today's implementation, we will update our current service to make it a little more robust and then implement the Axios version of the same service. So, what we'll do as a part of our updates are we will add the error handling to our service. So, right now, the bare bones structure would change a little. And you would have a centralized error handling available. And apart from that, we'll also add some logging capabilities to our service. So that way, when we migrate the service to Axios, it would be a fully featured service rather than just a bare bones implementation. So with this, let's get started on updating our service. So here is our application. The server is already running on port 3000 as we can see. And if you want to have a look at the current running application, here it is. We have the application where we've implemented routing. We can go to product details. We can go back to your home page. You can add the product to cart. Right now, it will only log the products in cart as we have added a reducer and a context, but have not implemented a carts page. But now going back to our service, this is our very basic service. So let's start upgrading this service to make it a little more robust and add the features of error handling and logging to it. As we've already discussed in our previous video, the response that we get from this fetch call is of response type. And in response type for error handling, what we can do, if response is okay, as in it was successful, then we process it. If not okay, then we can throw an error. Okay, something failed in the API. And that's how you implement error handling. But as we can see, this sort of code would be repetitive across all your methods. And we always want to ensure that we don't repeat ourselves when we are writing code. So what we do, we'll create a reusable function, which we will use as error handler in our case. So error handler, this would be an async function. It will take the response type as input, a parameter. If it's not okay, get the text out of the response. As we know, it's a response stream and it can be interpreted. The body can be of text type, JSON type, and other blob and others. So we are now interested in the text because we know something failed and it would be in a text format probably. So we'll fetch that text directly. And then we can throw a new error where we intimate of the response status. Then if we are getting some text from the error, we take that error message, else an unknown error. And if everything is fine, what we would do, we would return response.json. Now, instead of doing this, what we can do, we can just return await handle response, and we can pass the response here. But as we can see, we are also throwing an error which we need to handle. So we will move this entire processing inside a try catch block. So try catch statement, move both of these inside there. And in case of an error, what do we need to do? We will log that error, fail to fetch products, and then your error. And we will also throw new error. So this method get products is now using the handle response and is able to handle the errors if they arise out of our products API. Let's do a very similar implementation here as well for the product ID. We can copy paste most of the things. So your try catch block goes as is. And then fail to fetch product with ID. And here what we can do, we can convert this to template literals now. And here we go. So fail to fetch product with ID, and similarly fail to fetch. So error handling is implemented. Let's have a look at that. So no change in our service, but if I go to network and block this call, we would see in console, fail to fetch products, please try again later. So you're getting the appropriate response and error handling is working. It failed to fetch, and then you get the appropriate error from the fake store API. So we'll unblock the call once again and we'll refresh once again. Everything should be up and running as usual. Now we close this and go back to our service. The next thing we want to implement is request and response logging. So request and response logging. For that, since we don't have concept of interceptors with fetch, what we would do, we would create a custom fetch method where we will log the request before we send the request and response after we get the response, and use that custom fetch on both the places. So how we can do that is const custom fetch. So you will take the same parameters, your URL and your options, and which would be of type request init options. And this is something that's out of the box available definition. Now, before sending the request, we log it. So console.log. And what we log the URL, we log the method. If options object is available, then we get the method from that. Else, by default, if you make a fetch operation, the method is get. Headers, you might or might not pass it. So again, options, if it's available, read the headers, and then body. Options, if available, read the body. So this is your request logging. How we make the operation. So const response is equals to fetch URL and options. Now we log the response. So same URL status. What was the status of the response? And what were the headers that you got as a part of your response? So your response dot headers. Save it. And in the end, don't forget to return this response so that we don't break the chain. And now wherever we were using fetch, we will use this custom fetch instead. Custom fetch and custom fetch. Let's have a look at our application once again. There should be no change, but you should see some additional logs come out of our application. So here we are. Let's go in. I'll fix it to the right side and I'll refresh. Here we can see request is available and response also came. So all the logs will be repeated twice because React is running in dev mode. This is covered in the core concepts video, but yes, so it's not an issue. This is perfectly expected. So you're getting the request, it's method get type, and this is the product that we're fetching. And then you get the response as well. So you get the headers, status, and the URL from where you got that. So we are not getting any additional headers. That's why it's just an empty object of headers. Great. Everything is working now. Now, time to create a service using Axios, which will have all of these features. And we will discuss what changes from a basic fetch based implementation to an Axios based implementation. For that, first we need to stop the server and then we need to install Axios. So Axios is installed successfully and we can go ahead and start the server again. It'll start and we'll go back and under the API, let's create a new file. Fake store Axios API.ps. So it remains same, the similar implementation, but for Axios. Let's start with the implementation now. So first thing, we need to create an API client. How do we create it? So you create const API client is equals to Axios, and Axios is something that now you need to import. So Axios is imported. After that, it'll give you create method. And in this create, you can pass base URL, which would again be the same URL that we've configured here. So you can keep on referring to this particular service. So base URL would be same. And then you can also configure a timeout. So after how much seconds, if it's not responding, you should just time out the request, which we'll set it to 10 seconds. It's an optional parameter. You don't need to set it mandatorily. Then we need to fetch all products. In here, export const. And let's ensure that we are using the same name so we can interchangeably use the services if we want. So I'll take that entire thing, products, everything would remain same. And inside the implementation would change. Let's add the required imports. And then your response is, wait, now we are using API client. We are not using Axios directly. So API client.get. And now you can parameterize or you can give the type definitions of what you're expecting in the response. So we're giving the product type. And what do we need to fetch? Products. Adding onto the base URL, we'll be fetching this. And then what do we need to do? Return response.data. No errors, all good. Same thing we need to do here. Same implementation. But this time you're only getting a product. And what would be the API? It would be products slash the ID of the product, which we are already getting as a parameter. And then again, you return response.data. And now let's go to our product list. And in product list, we'll start using fake store Axios API. So here we see we are now using fake store Axios API. Now let's go back to our application and refresh it. No change in implementation whatsoever. But we see now we are not getting the logs again and we have not handled any errors. So let's add that onto the Axios service, the Axios way. So we go back to our service and this would be our error handler, error, and it would be of type Axios error. So type them correctly and we'll take the Axios error and this would return never, because we are throwing an error here. We are not returning anything from this. And now if error.response is available, then take data and then message property if it's available. If you get a similar error, I'll tell you how to solve it because we have not properly typed everything as of now. So we'll type that. If this is error.response is not available, in that case, error.message by default, which is available, a default property of all the errors. And then if even that is not available, then we need to ensure that we pass on the message that an unknown error has happened in our application. So here we have it. Then you log that error with the message and you throw new error with the message. And now how to solve this? It would be saying that property message does not exist on type an object because data is of type an object. So what we would do, we would create a new interface. And what would that interface do? Response. So you can create your custom interface. Interface API error response message, which would be an optional type. But if it's available, it would definitely be of type string. And then you can parameterize the Axios error. It takes in the type parameter, and we see error is gone now. It is able to understand, okay, if data is available, it could possibly have a message. And this response type that you see here can be customized as per your backend. So if your backend has a defined error schema, which it sends for every API error that it runs into, you can have the same schema here. For now, this is good enough for us. And then we need to ensure that we are using this handle API error everywhere in our application. And how would this work? So right now, how Axios would handle this error is there's a possibility that API client could itself run into an issue. And we are not handling that as of now. We are just moving with the happy case. But now we will implement try catch, move this inside. And in case of an error, now we will call handle API error, pass the error. And these type of error means that you're not adhering to the return type of the function. That means that try block is definitely returning a response of this particular type, but your catch block is not. So either it needs to return a type or it needs to break the execution completely. In that case, you can throw that error, and that would again resolve the issue. So this is the error, and here we need to typecast it properly. So we need to tell that it would be of type Axios error of type API error response, the same type that we are expecting in the method. And then this exactly the same implementation will go here. And now we have error handling available. So let's try and introduce an error and see if it works. All good. Let's block this again. Refresh. And in console, we can see network error, and it is coming from fake store API. So the type of error that we got and from which line it is coming, it is coming from our handle API error response. So we are throwing a new error and API error. What is the type of error? It's a network error, which is perfect. So our error handler is working perfectly. Let's unblock the requests and refresh once again. All good. Now, the last thing that we need to implement is the logger. In logging, as I mentioned, we would be using interceptors in Axios. It's a very handy feature that's available for someone who is very new to API clients and the concept of interceptors. So in a very large application, we usually have the requirements. You might have to send some custom headers, the authorization token or some session tokens from your client to the server for each of the requests that gets triggered. You might have to append some custom client names, some versions and other things. And we don't want to do everything where we are making the call. So for example, you're making a call in a component. We don't want to burden the component with that information. And the reason for that is twofold. First, every developer would have to be aware of that, which is not possible if someone new joins your team. Another thing, there is a change in the sort of headers that we need to send, we would have to find all the components where calls are going from and then update the implementation there. So to keep the implementation centralized, there's the concept of interceptor, which we would use today. How do we create interceptors in Axios? It's very simple. We just bind interceptors on the API client. So you already created your API client. Now on that API client, we would add a request interceptor. API client interceptors is an object which is available on your client. And then which type of interceptor do you want? You have a request interceptor and a response interceptor. So we want to add a request interceptor. And what do we want to do? We want to use a new interceptor. So you are creating a new interceptor in this case. And then the parameters that it takes a function which would automatically receive a config object. The type of that config object would be internal Axios request config. And this is all there in the Axios documentation. If you have worked with the client or if you're confused, what is the type definition that I need to use? You can always refer to the Axios documentation and it will give you the exact same type definitions. And now, once you get the configuration, we log the requests. So console.log, similar logging pattern that we followed previously. So URL, your config.url. And this is pretty much the standard logging for any of the requests that we see. We need to have the URL method, headers, and data. So ensure that you're not logging anything sensitive onto the console or sending it with the API. So if your data is handling something confidential like password, you don't want to log that password or send it somewhere. So just be very cautious that way. But this is just for a demonstration purpose. That's why we are doing this. So our request interceptor is configured. Let's have a look if we are getting the appropriate responses. And as you can see, we only created an interceptor, but we have not bound it anywhere else. It's bound to the API client, and the interceptors that are bound to the client will run automatically for all the requests and response. So when we go to console and let's refresh. You see, the requests are getting logged properly with the structure that we saw. And now headers are of type request headers. That's perfect. Now let's configure the same for response as well. And in this case, you could already do it. You can pause the video and try to do it yourself. API client dot interceptors dot response in this case, and we are using this new method. So response, and this is of type Axios response. Sometimes the types are really intuitive, so you don't have to worry too much about them. But yeah, it's always good to refer to the documentation. And in here, we can log. So response.config.url status. This time we are not getting the config object. So we are getting a response object which has a config property inside of it. And then your response.status data is response.data. And now what we would do, you can return response. We always want to ensure we are returning it from the interceptor. There's a possibility your response could be of error type. In that case, we need to handle that here as well. So error would be of type Axios error. And in that case, we will log the error. So we are just covering both the bases because request would not error out. You're sending a request. If it's a network error, then only in that case it errors out, which is already handled. But when we are configuring an interceptor, you could get a positive response or you could get a 500 or something from the server if your server crashes in between the processing. And we are handling that as well, just to be sure. So error response, log that out explicitly, and then exactly the same thing. But in this case, we will use the error object. So URL would be error.config. And in case it's available, give me the URL, status, error. Now error has a response object of which we want to get the status, whether it was 500, 403, and then your response data that we got. So again from response data. And in this case, what do we need to do? So we still need to return, but what do we return now? We can return a rejected promise. So your promise reject, and reject it with what? We will reject it with error. And that's it. Your response object is properly configured as well. Let's go back to our application, refresh, and see request and response both. So response is also available. We got all the data, the status, and the products. So your logging is also working perfectly now. And this is your Axios implementation of the service. One thing which I want to call out, it's perfectly normal to use two different clients for two different sections of your application. So as we can see in product list, we are still using the fake store Axios API. But if I go to view details, since we did not make any changes, view details would still be using the normal fake store API. And we can see the logs are coming from fake store API. So two different API clients, perfectly fine, perfectly normal. But it's recommended to have just one client because you want to keep the service information centralized as well. And you don't want to include a lot of files in your JavaScript bundle. So it's always recommended to have just one, but it's fine if you have two different versions. It won't cause any issues as long as the input outputs are same. So, and if you have a look at the input output, the input output type of fake store, even the name of methods is exactly the same going from one service to another. So time for a quick recap. What did we do today? We revisited our service to make it more robust. We added the error handler as well as some logging to our fetch based service that we had. The bare bones service is now very robust and able to handle the errors. And then we implemented the same service using Axios, and we also understood why do we need to use Axios, all the features that we talked about in the beginning of the video. And then we implemented this very same service with the same method names and the return types using Axios. How do we implement it using Axios? You need to create a client, which would be configured using a base URL. Then we configured an API error handler where we pass the error type in case we run into an error. And we log the appropriate errors and throw the error message. And same thing we did on our methods where we are fetching the products and products by ID. Once this is done, we implemented logging using interceptors. So we configured a request interceptor to log our requests, and then we configured a response interceptor to log our responses. In this, we ensured we're covering both the paths, the happy case where you get a proper response or an error case where your response errors out. And then we updated the imports of our product list page to get the get products from fake store Axios API. Since there was no change in the calling pattern, we did not have to make any other change in our application. And we also saw that different sections of our application can continue to use different clients, even though not recommended from a dev workflow perspective, because you want to keep the services centralized for better debugging and easier maintenance. But it's perfectly fine. So one section of our application is using the Axios API, and the other application is using the Fake Store API. And since the signature implementation signature is exactly the same, you can update the second section as well. So you can go to product details page, and in there as well, we can implement it using Axios API, and this would also work perfectly fine. If I refresh it now, our entire application is now using Fake Store Axios API. So if you go, you see all the logs are generated from there. You get the request and response and a valid error handling as well. There are additional ways and design patterns to handle errors even more effectively. You return appropriate error types. So you don't just throw a new error. You can throw specific error types and then catch those specific error types to make a much more robust error handling system. But all that's in the future. So now we have an understanding of what a good and robust service looks like. You would definitely have more methods as you expand your application. If you're dealing with the entire threat operations, you can have different versions of the application. So a single client could be responsible for adding your users, getting your products, handling the shopping cart and other functionalities. But the same client will be used in different files so that you don't overload a single file and it's still maintainable. All those are slightly advanced project structure concepts, but that's how you scale. So this is what a basic robust service looks like. Hopefully you were able to understand everything we did today, and it was able to give you a good foundation of how to go about creating a service and what did we not do in our bare bone service. In case you come across any issues or not able to resolve something and not able to understand something or want me to cover some concept in greater detail, please let me know in comments and I'll be more than happy to assist in the best way possible. Thank you for joining in. Have a great day.